Hi students, good morning. Once again, welcome back to our physics classes. This is the first class after our second semester, that is your first pre-board examination. And I was going through your answer sheets, and this time I am not so satisfied with your answer sheets. Take these opportunities, that means these two pre-boards, one already over, in the right sense, which means you have to consider these the next coming pre-board, that is this year second pre-board that begin on 4th of January. Take it in the serious sense. The whole portion will be there for your second semester, second pre-board examination, and you approach the examination as you go for your board examination. Take it as a dress rehearsal for your board examination. Try to cover all the portions. I have already told you many times, we have already finished our chapters, and you have to go through all the concepts well and prepare it as you prepare for your board examinations. Okay, today we are going to discuss the last pre-board question paper. That means the first pre-board question paper. See, the question paper was not too tough, but comparatively easy question paper I made. But common errors that you have made in some questions that we will discuss now. So starting with the question number 1. The first question is multiple choice question, that is the angular frequency of an AC at which 1 millihenry inductor has a resistance of 1 ohm. So angular frequency omega you have to find out with the L omega is equal to 1 ohm. When L omega equal to 1 ohm, then omega should be 1000. That means 1 millihenry is the L, then 10 to the power minus 3 into omega is equal to 1 ohm, so omega is equal to 1 by 10 to the power 3. 1 by 10 to the power minus 3, that is 1000. Then the Lyman series of hydrogen spectrum lies in the region of ultraviolet. Then interference occurs in which of the following waves? Longitudinal, transverse, electromagnetic, and all of the above. Longitudinal waves, sound waves can superpose. Then transverse waves can superpose. Electromagnetic waves also can be superposed. So the answer is all of the above. The rate of change of current is 5 ampere per second, induces an EMF of 50 millivolt in a coil. What is the self-inductance? You know, L into di by dt is equal to V. So EMF is given 50 millivolt and di by dt is given 5 ampere per second. Then L should be 10 millihenry. In a nuclear reactor, cadmium rods are used as control rods that we have discussed. Then, next question is one of the confusing questions, that is, what is the condition for resonance in series LCR AC circuit? This is the property of that LCR AC circuit, LCR circuit. It is known with the frequency matching. Frequency matching occurs only when this LCR circuit satisfies a condition. What is that condition? Its impedance should be minimum, and for impedance should be minimum, impedance should be equal to the resistance. So for that, what is the necessary condition there? The necessary condition is reactance offered by capacitance should be equal to reactance offered by the inductor. That is, X is equal to XL. That is the condition for resonance in LCR. Many answers I got means impedance becomes zero. Impedance will not be zero in an LCR circuit, that you remember. Then frequency of the supplied voltage or should be equal to the natural frequency of the LCR circuit. That happens only when this condition is satisfied. So the necessary condition is XL is equal to XC. Then define magnifying power of an optical instrument. If you are talking about a mirror or a lens, you can consider it is height of image to height of object. But for a optical instrument, you have to define it in terms of angle, that is beta by alpha. So HI by HO, that is the wrong answer for this. So one type of wavefront is produced by a point source. Spherical wavefront is made by a point source. Then what are coherent sources? Coherent sources are the two light sources which can provide you light waves with the same frequency, same amplitude, but important factor is there is a zero phase difference or path difference or a constant path difference throughout. That means constant path difference or a phase difference which is not changing with the time. That kind of sources are called coherent sources. Okay, so coherency means there is no change in the path difference between the light waves. That is important. Find the focal length of a lens whose optical power is minus 5D, minus 5 diopter. So how you can find out the focal length from power? 1 by f is p. So 1 by p should be f. So it should be minus 1 by minus 5 meter because diopter is meter inverse. So when you are taking the reciprocal of diameter, the diopter, that will give you in meter. So that will become minus 0.2 meter. Minus 0.2 meter means minus 20 centimeter. So the unit is very important there. If it is written 0.2 centimeter, that is wrong. And it is written as 20 centimeter, that is also wrong. That negative sign is also important there. Okay. Then draw a labeled graph of an angle of deviation versus angle of incidence for a prism. That diagram you are knowing. First it is decreasing, then it increases. Calculate the angular momentum of an electron in the third orbit of hydrogen atom. Third Bohr orbit of hydrogen atom. So you know angular momentum is an integral multiple of h by 2 pi. So it's in the third Bohr orbit, then it is 3h by 2 pi. If it is written 3h by 2 pi, it will not carry any mark because the question is calculate the angular momentum of an electron in the third orbit. So you have to calculate 3h by 2 pi and that final answer only carries mark. That equation will not carry any mark since it is a 1 mark question. Okay. So this is the 12 questions from the question number 1, 12 subsections of question number 1. Among this, I don't think any of this is too tough, but I already told you, confusing questions are there. Means common errors we made in this LCR circuit question, then optical power question. Okay, so keep in your mind these main factors. Then we are going to the section B. In section B, we are having question number 2. The radius of the first orbit of the electron of hydrogen atom is 5.3 into 10 to the power minus 11 meter. What is the radius of its second orbit? You know, radius of atom, atomic radius is given by n square h square epsilon 0 pi mz e square. So the first orbit means n equal to 1. So that is given as 5.3 into 10 to the power minus 11 meter. For the second orbit, it will be n square will be 4. So first orbit multiplied by 4. That will be the answer. So 4 into 5.3 into 10 to the power minus 11. That is the answer for that question. Question number 3. An electron is accelerated under a potential difference of 150 volt. What is its de Broglie wavelength? How you can find it out? Under root 150 divided by V, or 12.27 divided by under root 150. Under root V. V is 150. So it is always 1 angstrom. What is meant by pair production? It is very clearly given whenever photon falls on a heavy metal surface, it is converting into a pair of electron and a positron. It is an example for converting energy into mass. That's the perfect answer for this question. And you can give that H nu equal to h nu gives beta plus 1 0 plus beta plus 1 minus 1 beta plus 1 that is beta plus and beta minus. The two particles are created, that is positron and electron. What do you mean by atomic mass unit? Atomic mass unit is 1 by 12th of mass of one carbon 12 atom. 1 by 12th of mass of one carbon 12 atom. And it is, we have to express in kilogram. It's a 2-mark question. So you have to express it in kilogram also. A simple microscope with a focal length of 5 cm forms an image at a near point of the eye. Find its magnification. If the image is at the near point of eye means at 25 cm. Near point is 25 cm. So what will be the magnification? 1 plus d by f. So 1 plus 5, that is 6. 1 plus 25 by 5, that is 1 plus 5, which is equal to 6. How can you convert a galvanometer into ammeter? Draw the circuit diagram. How you can convert galvanometer into ammeter? By connecting a low resistance in parallel with the galvanometer. By connecting a low resistance in parallel with the galvanometer. Connection diagram you know. How does inductive reactance vary with the frequency? You know, XL is equal to L omega 2 pi FL. So, directly proportional with the frequency. So, you have to express that equation. XL is equal to L omega 2 pi LF. Then, you have to say that it is directly proportional. Or you can draw that graph also. Question number 9. A transformer is used to step up an EMF of 200 volt to 440 volt. If the primary coil has 1000 turns, calculate the number of turns in secondary. Vs by Vp is equal to Ns by Np. So, Ns is equal to 440 divided by 200 multiplied by 1000. Question number 10. Write any use of infrared radiation or X-ray. Direct question. Define dispersive power of a medium. Angular dispersion, difference in angular dispersion to violet and red divided by mean deviation for yellow light. Derive expression for self-inductance, derive expression for mutual inductance. You can express either in terms of phi or in terms of E. Phi is equal to Li. Phi is equal to Li. So, L is equal to phi by I. Or E is equal to minus L into di by dt. So, L is equal to E by minus L is equal to E divided by di by dt. Any of these equations you can use. Then question number C. Section B, all are easy questions, not confusing questions are also not. Then question number 13. State and prove Faraday's law of electromagnetic induction. State and prove Faraday's law of electromagnetic induction. That experiment we are having a U-shaped bent metallic loop. One side is moving, it having a current, and E is equal to BLV, and BLV is equal to d phi by dt. Then you can compare both, and you can arrive at E is equal to minus d phi by dt. That experiment, through experiment only you are proving that. Okay, so that proof is that experiment. It's very clearly given. What are eddy currents? Explain how they are produced. What are eddy currents? Eddy currents are the current generated in the bulk of a magnetic material when the flux associated with it is changing. Then, using wave theory, explain reflection of light or refraction of light. The diagrams, I already told you many times, the diagrams are important, and carefully you have to make the diagram, and that will give you the answer for that question. Then, question number 16 is focal length of a thin convex lens is 20 centimeter. When an object is moved from a distance of 25 to 50, magnification changes from m1 to m2. Find the ratio. So, m1 is equal to f divided by f minus 25 m1. m2 will be f divided by f minus 50, f minus u. Then m1 by m2 will become f by 50 minus f by 25. And then the answer will become 6:1. That is also made wrong by many of you. Then question number 17. Draw a graph showing the variation of stopping potential with the frequency. How can the value of Planck's constant be determined from the graph? That graph with the straight line cutting x-axis and meeting on the minus y-axis, and from that graph slope is the Planck's constant. Define isotope, isobars and isotones. I mean, when I said this question, I believe that all of you will make it correct. But fortunately, unfortunately, you some of you have made it wrong. The interesting fact is some other questions they made correct, but the easiest one you made it wrong. So isotopes are atoms with the same atomic number but different mass number, and isobars are having same mass number but different atomic number. Isotones are atoms with the same number of neutrons, not nucleons, same number of neutrons. Okay. So the binding energy per nucleon for helium nucleus is 7 MeV. Find the mass defect. This is the binding energy per nucleon. So the binding energy will be binding energy per nucleon multiplied by the number of nucleons in there. Since it is a helium nucleus, how many particles will be there? 4 particles will be there. So 4 into 7, 28 nucleons will be there. So sorry, 28 by energy will be 20 MeV. Then if it is given in MeV, it is easy to find out the mass defect in AMeV, atomic mass unit. That means delta M is equal to binding energy divided by 931.5. Or it is given in the joules, then you have to use delta M into C square. If the binding energy is given in the joules, then you have to use delta M into C square equation. If it is given in MeV, you can directly use that equation. Binding energy is equal to delta M into 931.5. Okay. So that are the questions from section C. Then in section D, define Huygens wave theory. 3 postulates we have discussed. That 3 postulates is required. There 2 marks for that. Describe Young's double slit experiment and derive the condition for constructive interference and destructive interference at a point on the screen. See, this is during the class time and the revision time I stressed this experiment that how you have to derive these equations. See, the diagram is important there, and you have to consider the central point O. Then the path difference you have to define, and if the path difference is 0, that point O will be bright point. Then you are assigning any arbitrary point x. X can be bright point or dark point depending upon the path difference. So if the path difference is an integral multiple of lambda, then that is will be a bright point. For that you have to first of all find out the path difference between S1p and S2p, or S1o and S2p, and you have to give that S1p S2p minus S1p is equal to xd by d. Then from that xd by d is equal to n lambda, then that will be a bright point. Xd by d is a n plus half lambda, then that will be a dark point in that sense. So it is not required that I1 and intensity equation I1 plus I is equal to root of I1 square plus I2 square, that is general equation only. So it is clearly given at a point on the screen what will be the condition. That is the condition path difference is integral multiple of lambda or n plus half lambda. Define Fraunhofer diffraction at single slit, obtain the angular width. Bad question. Derive equations for radius, velocity and energy of the first orbit in hydrogen atom. For example, we are having Rn is equal to n square h square epsilon 0 pi mz d square. When you are considering the hydrogen atom, z will become 1, and when you are having first orbit, n will become 1. So you have to derive the equations and you set z is equal to 1 and n equal to 1 in that equation. Okay, then state postulates of Bohr atom model. You know that. What do you mean by emission spectrum? Draw emission spectrum of hydrogen atom. Many times I told you how to make the spectrum and energy levels, how you can express that energy level, spacing between the different energy levels as you go for the higher energy levels, then the transition each series band, and that equations 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. So all these you have to be make thoroughly there. State the basic principle of AC generator, electromagnetic induction. Then with the help of neat diagram, explain the working of AC generator. Draw the ray diagram for the compound microscope set for normal adjustment. When you are setting the normal adjustment, the final image is at D only. Then the object of the eyepiece within the focal length of it. That means image formed by objective lens will be within the focus and lens of the eyepiece. Then only you will get the normal adjustment. Then derive the magnifying power. So comparatively, easy question paper. Some questions, as I already told you, all of you, most of you made wrong. That is confusing questions I already told. So while preparing for the second pre-board, keep all these matters in your mind and watch the classes properly. I already told you the pattern of board examination is somewhat different from the competitive. So take the instructions given seriously. That will affect your board examination marks. That means board requires steps, and if the steps are missing, you will not get marks for that. Many times I told you. So please keep in your mind all these matters while you are preparing for the second semester examination. Sorry, second pre-board examination. So prepare well, and we will meet in the next class.